Hello everyone again. We're back again now talking about the circumference and the arc length of circles. I'm going to start off with a couple of problems where we find the circumference. This is not anything new to you guys. You've had circles before where you had to find the circumference. The circumference is just the distance around this circle. So if I were to cut this rubber band, I cut it and I lay it flat on a ruler, I could see how long it is. Of course, every circle you're not going to be able to do that, and you probably can't wrap a ruler around it. Maybe if you had a tape measure, but we don't always have that as a resource. So of course, we know that that there is the relationship of pi, where pi is the ratio of any circumference to the diameter. I'm going to write that down just in case you haven't seen this before. That pi is the relationship of the circumference to the diameter. And if you multiply both sides by d, you get d pi is equal to c. So c is equal to pi d, which is the diameter is 2 times r, and so we usually write it like this. So the circumference is 2 pi r. Let's say we have this circle. All right, this is circle X, and it has a radius of 3 centimeters. If I have circle X with a radius of 3 centimeters and I want to know the circumference, I just simply put it into this particular formula, 2 pi times 3. And we will write that this is 6 pi, or to one decimal place, we'd say that it's 18.8 centimeters. All right. So depending on what type of answer you want, if they say leave it in terms of pi, you'd say 6 pi. They said to one decimal place, you'd say 18.8 centimeters. That's one example. You could also have a circle. Let's bring one more circle down here. Let's call this circle, I don't know, I didn't give this one a name. My notes here. Let's give it a name. Anybody know? Let's call it circle Y. I heard you. You said circle Y. It makes sense. It's after X. So we have circle Y. And I drew a diameter in it this time of 16 feet. It goes all the way across the circle. And so then we could find the circumference, which is pi d, right? Or we could have cut this in half and put 8 in place here. But since we do have the formula with the diameter, I put 16 in place, which is 16 pi, or just 50.3 feet when you leave it in one decimal place. So this is the actual length if you were to lay it out on a ruler of this entire circle. That is what circumference is. We know that the entire angular measure, which would be the entire arc measure, because the central angle has the same measure as the arc measure of the entire thing, would be 360 degrees, right? So that is kind of the difference between what we're thinking about now and versus what we talked about in the previous videos. Let's go forward now and talk about the arc length, because the arc length now says that I don't have to find the entire circle. Let's just say I wanted a piece of the circle. So I'm going to go ahead and clear this out and start again with this whole idea of the arc length. Let's say I have this circle. It's going to be circle Q. And I want to know the arc measure of the arc length of arc AB. So let's say they said find the arc length now of arc AB. All right, so this is a big question in my head because I want to know the arc AB. By using these two letters, AB right here, it lets me know that they're talking about this arc right here. And I do need to put some more information on my picture. There's a right angle in there, and that this will be 14 inches, which is the radius. Now, I can find this arc length by thinking in the same terms that I just did for the circumference. The arc length, or the distance from A to B, would be a fraction of the entire distance if I were to go around the circle starting at A and ending right back up at A in the end. So just using those exact words, the arc length is a fraction of the circumference. is a fraction of the circumference, right? It's a piece of the circumference. It's not the whole circumference. It's just a portion of it. Well, using that thought process, I come up with my formula. The fraction is some measure out of 360. Well, here's the difference. I want the arc measure at this time. So it's the measure of this arc AB. Of in math, we know that to be multiplication. So it's the measure of the arc AB over 360 divided by 360 is that fraction of times the circumference. Circumference is 2 pi r. Well, now we can find the length of this arc. I'm going to highlight it so we'll know that this is what we're looking at right in here. This is the arc that we want. Now, if this is 90 degrees, you can look at this and visually say, well, that is a fourth of a circle. You're going to see how that plays right into what we're doing here. What arc measure do you have? Well, the arc measure is the same as the central angle, which is 90 degrees. This is all in degrees. This is not talking about the inches that you see in there. It's not a length. It's a measure. It's saying how much does it bend. It's 90 out of 360 times 2 pi. R was 14. 90 out of 360, if you were to simplify that, that would be 1/4 of 2 pi r, which 2 pi, or 2 times 14, you could go ahead and write that as 28 pi. So the entire circumference is 28 pi, and then this is a fourth of it. That makes sense because the fraction fits the situation. This is a fourth of the entire circle, 90 out of 360. So when you do that, you get 7 pi, and we're in inches, or if you put, so I could say 7 pi inches, or if you put instead something like they said, put it in the nearest tenth, you would have to put 22.0. It's 21.99, which we know we would have to round it to 22.0 inches, because again, this is a length and not an area or something like that. It needs the units on it. So that is the difference between the measure, how much it bends, versus its actual length out there. Let's get another example of this type. If you need to pause and slow it down, that's fine, but I'm going to keep moving on count of time. One more example of this type. We're going to find the arc length. Again, this is another circle. This will be circle P this time. Circle P. And this time, all right, I'm going to put a central angle over here. And the C and E, we have a radius of 9 centimeters. I also need a point D out here. This is circle P, and let's suppose they ask you to find the arc length. Oh, one more thing. I need to put in my angle measure there, 40 degrees, okay? Let's say they want you to find the arc length of CDE. Okay. Again, now I have to take a look at what they're asking me to find. So I get this problem. They say find the measure of the arc length CDE. CDE. Now, visually, I look at this problem, and I'm going to see that 40 degrees and think, oh, there's my information. I go for it. But if I haven't paid attention, then I would have missed that that's 3 letters. So that must be either a semicircle or a major arc, which CDE, if you follow it along, CDE around the circle, that must be that major arc that they want me to find. So when I set up my fraction of the circumference, it's not going to be with the 40 degrees. It's going to be this degree measure around this way. Well, the whole circle is 360 degrees, leaving you 360 minus 40, which is 320 for the rest of the circle. So my fraction is 320 over 360 of, or times, 2 pi, and r is 9. Okay, so that's the little tricky piece that you have to pay attention to what they're asking you to find. Now the rest is just simplification. So 320 over 360 is 8 over 9. So that's 8/9. In other words, this piece over here is just 1/9 of the circle. I want 8/9 of this entire circumference, which would simplify to 18 pi. And when I multiply that together, I end up with 16 pi centimeters. Or if you wrote it to the nearest tenth, that would be 50.3 centimeters in this case again. All right. Very good. So we'll keep working with these central angles inside the circle, finding next the area of sectors. See you later.